You're muted.
Thank you so much. Perfect. Um, my apologies. Yep. Today we're going to do an overview of the Python language, and we're going to start with and actually Max and James, if you guys are here, I know you said there were some internet issues, but when they're resolved, can you hop on camera, please? Thank you. Um, we're going to talk about types, variables, basic control flow. Python has a lot more nice data structures. We're going to see tuples. We're going to see sets. We're going to see dictionaries. Not the same as JavaScript objects, similar but different. And the term object kind of has a slightly different meaning in Python. We'll really dig into it next week. Suffice to say that JavaScript has objects, but it's not really an object-oriented programming language, which might sound a little weird, but when we get into Python OOP next week, we'll see what that means. So just file away. JavaScript has objects, but it's not really an OOP language. Functions are actually more important in JavaScript than objects. Um, we're also going to look at a switch case statement. Lambda functions are the same, very similar to JavaScript arrow functions. We've seen map and filter yesterday. We're going to see how to deal with errors in Python. And we're going to talk about importing and paths in Python as well. The final part of the lecture, and like we'll take breaks every hour, and I think we should be able to get through most of this, either all of it in the morning or have some work time and then finish it in the afternoon, will be about testing. And there will be a couple really important things here, particularly this monkey patch and capsys when we get there, because the OOP assessment at the end of next week will heavily involve these. So really from now through all of next week and basically the following week, it's going to be all Python. So this is definitely what to focus on. Let me go ahead and make a file and open it up, and we can start writing some code. So first off, if you want to make a multi-line comment in Python, you use something that Python calls a doc string. And it's like this. And just like JavaScript has JSDoc, there's standards and sort of conventions around how to use this. I think you've all seen single line comments in Python with the pound sign. Real quick, in VS Code, I can actually highlight multiple lines of code. I'm just doing this with the mouse. And if I hit Command slash or on Windows Control slash, I can toggle commenting that whole block. So this is actually really useful. And we don't have console log in Python. We have print statements, right? And I didn't save my file. And now it'll run. So let's talk about Python data types. Python has numbers. And we can use a function called type to get the type of an object. Because everything in Python is an object. And actually, let's see if anything in Python is not an object. There might be one or two things. Is everything in Python an object? So, unlike JavaScript, I believe even like true and false are objects in Python. And we can test this out as we go. So, because everything, yep, even true and false are objects in Python, We'll learn about classes next week. But since everything is an object in Python, making it a true object-oriented language, unlike JavaScript, type gives us the type of all these objects. And you can see here, the way it does it is with these angle brackets. We'll learn about classes next week. Objects get kind of organized into different classes or categories. And so there's a class integer. And if I go ahead and, I make a floating point or decimal number, like say the value of pi 3.14159, and we print that out, then we see that unlike JavaScript, Python has an int type and it has a float type for decimal numbers. But Python kind of sets that up automatically for us. And let me give us a little more real estate so we can see this as we go. And also, I'll close this out because we don't need this for now. And let's just go ahead and like print the types of some other things. Let's do a string. Let's do true. And true needs to be with a capital T in Python and false with a capital F. And then instead of null, Python has a value called none. And here we see true and false belong to the Boolean class. None has its own type, and we have a string class as well. Do folks have any questions sort of about this overview of data types, or the agenda for the day, or anything else before I keep on rolling? Right, and these are the basic ones. We'll learn about lists and dictionaries and things like that in a little bit, but these are, our very basic building blocks. There's a couple nice things we can do with strings. For one thing, I can use something called an F string for string interpolation. Let me comment out those old print statements. So if I type F single quotes, I can put variables inside here like this. And then we see down here the message with string interpolation with the strings combined. And you can combine these together. Because an F string creates a new string, right? And I had an extra period here that I didn't need. Maybe I'll get rid of it over here. And then there's a bunch of different ways to manipulate and work with strings in Python, just like with JavaScript. Um, do folks have any questions around strings, or does anyone who's worked with Python want to share? Is there like the one cool trick you really like with strings?
I like that in with Python you can iterate through a string and reverse it just using the index iteration.
Oh, you want to walk me through how to do that? Let's do that with our message and go through it and reverse it.
All right. I have to remember how to do it. Um, All right. So, in Python, when you're going through a string, you use a colon to, you can start at the index one and then you colon to the length of the string. One
Like that.
colon. Yeah. And then it gets colon again at -1. You understand what I'm talking
Well,
about?
you actually don't need the first one. Just colon, colon, -1.
Okay. Thank you.
Oh, no problem.
So
And
what are
so colon is the length of the string,
mhm.
and then you're going through the entirety of the string, so the length of the string, and the -1 is the iterator. So you're going to go backwards instead of going
So
starting at
you
index
actually
one.
you need two colons
Yeah.
and a -1 to go the other way.
So does this, let's
No,
build it up piece by piece. Does
you need
this do anything?
you need
You
two
need an
colons.
extra colon.
Yeah, two colons in a row and then -1. So you're going the length of the string. The first colon means the length of the string. The second colon is
Mm,
the the break, like the divider, and the third one is the iteration step. So you're going the entire length of the string, and you're going -1 in increments of -1. So you're starting at the end of the string instead of the
nice.
beginning.
What if
So
I
you
just,
so
oh yeah, go ahead.
you have start
Hmm.
to the end of the string and you have reverse. So it's three parts: start, and reverse.
Start, stop, step.
Exactly, step. Yeah.
So I've got start, stop, and then how do I add the step in here again?
Another colon.
Another colon at the end.
After three, you have another colon. And
Uh, and then step tells me the direction to go in.
yes,
How many places you're moving per. So if you did two, it would do two steps, like two indexes at a time. The negative just is like which direction you're going.
Love it.
Because in Python, if you use a negative step, instead of just starting at the beginning of the string, you'll go backwards, starting at the last index.
yeah.
Yep. And this is where I think Python really shines. I love JavaScript, but man, Python is a language with features. You can do all this stuff with it. And once you see it, it makes sense. Because how cool is this that we can start at the zero index, go forward one, two, three, four, five, six characters, and get every second character L, one, two, T, one, two, S, right? And then, like you guys were saying, if I want to do this from the end, I just got to stick a -2 on there. And I did something wrong here. Probably because, can someone help me fix this?
Well,
I want
you,
to go
you have to
backwards.
start from six and go back to zero.
Mm,
Yeah.
like so?
Yes.
Yeah. And if I wanted to start at the very end, I would do it like this.
Yeah, exactly. Yes.
Awesome. Thank you.
Oh,
We almost got there. Maybe, maybe it should be like that because I have my second colon. No, if I want to start at the very end and like print every second character, um,
Just do two colons, kill the
I,
zero.
I guess you could skip to
No,
zero.
that's working.
Is it working? Oh, okay.
Yeah.
oh, I think you guys are right. And then if I wanted to stop at -6, would it look something like that?
Oh, I believe the -6 should
Yeah.
be on the start, right? You're going all the way down to, am I wrong?
No, no, you had it right. If you wanted to start it, you wanted to do the entirety of the string backwards, but stop at index -6, going backwards, then you had it right. Colon -6, uh, -2.
Oh, okay.
Yeah. And in fact, the way to debug this actually, so I've been kind of guiding us a bit. And, like I said, I don't memorize this stuff. I do it when I need it. So here's the most useful debugging tip ever. Simplify, right? We can get it working backwards with one. And now that seems to be working, though it's so hard to to figure it out intuitively because I have to, go NOONR and use simple examples. Now let's replace it with three, right? Because I should only see two of these. Starts there, 1, 2, 3, or maybe 1, 2, 3, and then we get an N. It looks like N, 2, and then 3, something like that. We're close. We're in the ballpark. Point being though, there's a lot of really nice stuff that Python can do with strings, and we can do all this same stuff with Python lists, right? And under the hood, Python might be using a list for this string. I'm not sure. And lists are similar to arrays, but a lot more powerful
I do have a
and
quick
frankly
question.
better. Yeah, absolutely.
Is there a benefit to using like F strings compared to just, I guess, a regular string? I mean, obviously it makes it a little easier to just be able to put the squarely bracket in there with a variable name, but
Mhm.
is there like an actual benefit to doing that other than, I guess, like ease?
No, I think it's really just ease. Um, I'm not sure off the top of my head. Like, let's see here. I can't remember if the plus symbol works to concatenate, to combine strings in Python. Um, it looks like it does. It's really ease. Yeah, there's nothing specific. It just ends up being a very flexible tool. Yeah, good question. So lists, we've kind of gotten a preview of this, but we can do all these same cool things with lists. Yeah, I don't even know if cucumber's a berry. Someone, someone who wrote this curriculum thinks all these fruits are berries, and I'm going to trust them. So a list, frankly, is better than a JavaScript array. And we access elements in the list the same way. It's zero indexed. So I could do berries 1. I could do berries 3, and that would give me 0, 1, 2, 3, the banana berry. And then as we've seen, there's a lot of really useful ways to manipulate lists with this slicing. I can do plain old -1 to start at the end and go backwards, right? So -1 is here, -2 is here. And then we kind of saw slicing already with strings, but just for fun, let's see slicing in action with our lists. So what is this going to print out? Can someone tell me?
It's going to start at 0, 1, 2, cucumber, and then go,
Yep.
Cucumber and go to pumpkin.
yeah,
Yeah.
watermelon.
Yeah,
Oh, yeah,
Jack, I think you had it.
Watermelon.
Cucumber,
yeah,
banana, watermelon. Let's see, 2, 3, 4. I think
yeah.
that will be what it prints. Let's run it and find out. I heard some other folks jumping in as well. Thank you. And close,
Because it's up
we
to but
didn't.
not including.
Yeah. Say that one more time.
It's up to but not including the four. So 0, 1, 2, 3, 4.
Yeah, and I think this is an easy gotcha. And I'm just always, like I said the other day, like I always have another terminal open if I can get, there we go. Like I'll
How would
always
you
have
get that last one
a
included?
REPL.
Use a higher number. Use 2 through 5, and then it'll go 0, 1, 2 is cucumber and banana and watermelon, but not include 5.
Cool. That's what I thought. Thanks.
Yeah, exactly. Exactly.
It works the same way with the range command when you're iterating through something using a range.
Yeah. And it's always good to be thinking about with these kind of slicing type operations, is it inclusive or exclusive? Because it's a little different. Like in JavaScript, the behavior is a little different. So I'm always double checking. And like I said, I just always have a Python REPL open and I'll just do like 1, 2, 3, and then I'll just do a little slice operation here. Like I think I can do like 0:1, right? And if you guys look down here where I've got the Python REPL running, so I can just type lines of Python code and run them, I'm not even worrying about making a variable. I've just got a list and I'm applying my operation to it, right? And this can be, I highly recommend getting into this habit because for little stuff like this, it's really nice to just be able to run a little bit of code and like run a tiny experiment and confirm that it does exactly what you want, rather than be like, I'm 75% sure, and then an hour later you have a bug that takes you 40 minutes to track down. Awesome. And then we saw, like folks were saying, if I want to slice from the start, and I didn't quite understand when people were saying this earlier, I can just stick a colon. And if I hop back over to running my file, we can run this. And we see we slice at the start, and we go to index 3. So I this I have to talk through this. We're still not getting index 3. It's index 0, index 1, index 2, right? Index 3 is still included. I really think with this indexing stuff, this pointer stuff, this zero index stuff, I like writing stuff out and I'll like manually walk through it, and I have to do that all the time. And that helps me just keep straight with things. Um, so there's more stuff you can do with lists, but this is a pretty good overview. Um, and of course, we can have lists of lists, right? If we wanted to. Like we were seeing yesterday. And if I wanted to get the last name of the second user, I would do this. Anyone have questions or things you're curious about or want to dig into a bit more with lists before we move on to our next data structure? Cool. And yeah, of course, with the list, I can change the value of the things in a list. Um, and now if I run my code, if I put this print statement over here, we get Simon Garfunkel. Let's talk about tuples. Um, Anyone want to take a crack at just maybe giving like a short description of what a tuple is in Python?
Isn't it like a list that doesn't change?
Exactly. Yeah, exactly. You hit the nail on the head. It's a list that doesn't change. And in computer science, you'll hear the term immutable. Think like mutate as in change, and then immutable as in not. And those, especially like when we get into some React stuff that is sort of like functional programming later, those terms will pop up. So yeah, tuples are immutable.
Does it work the
And
same way as like const in JavaScript?
say that again.
Does it work like similarly to const in JavaScript?
Fonts, Fonts.
Const,
Oh,
const.
const. Great question. No, does not. Um, they both, an electric car and a gas motor car both look like cars. They both get you to the same place, but the engines are drastically different, right? So, and if you're driving a Tesla, there's like regenerative braking and it slows down as soon as you take your foot off the gas. You don't have to shift gears. So there's some real differences. So yes, a const in JavaScript is immutable, though as we saw, it's not if it's an array or an object, because you can add things into a const array. And a tuple is immutable, but they work quite differently. And this is like true immutability. Like once I define this tuple, I can't change anything about it. Does that make sense? Because yeah, accounts in JavaScript is sort of immutable, but if you guys remember from yesterday, this is going to work just fine. I just modified that array, even though it's a const, right? And the reason for this is arrays are passed by reference, and the const isn't really paying attention to anything that's inside it. Now, if I try to do this, it will complain. But when we talk about immutable, we don't expect to then be able to modify the array. However, in a tuple, and let me just go ahead and print this just so we can see it. If I try to modify the second thing in it, I get an error. Right? And if I scroll up a bit, well, it looks like I might have a syntax error somewhere else. Let me just fix that. Oh, and I'm running the wrong code. There we go. So unlike a JavaScript array, you really can't modify a tuple. It is truly immutable.
So,
Right?
so
And
that includes like you can't like add something to the end too, I guess. So you couldn't add Saturday, for instance.
correct. With lists, I should have shown this, by the way. Um, it's not push in Python, it's append, which is actually a bit better, and it adds something to the end of the list. So let's add Carol King to our users list and print that out.
Spring.
And fix my typo. Oh, yes.
Oh yeah, that's what I was saying.
Yeah, thank you. And so that works just fine. Here we have Carol King with dot append. But if I try to do the same thing over here, like you were saying, first of all, there's no append method on a tuple at all. So I'm going to get a different error saying that, hey, this object doesn't have this property or this method. And method is just a name for a function that's attached to an object. So I'm going to get a completely different kind of error here before we get to our second print statement. Tuple object has no attribute append. And even, right, and then we can't modify it. Does
And
that
and
answer
no,
your question?
yeah, and no equivalent, method. So we append list. There's no equivalent you said in a tuple to add something
You
to the end.
cannot modify a tuple, correct? Yeah. Um, what is a tuple useful for? Stuff like this, where in your program, this is never going to change. And if for some reason it does, I will just change this line of code, right? Or maybe, US zip codes, right? We wouldn't ever want that to change. US state or like country codes, like US, DE for Germany. I think ES is Spain, the United Kingdom, France. Like, I don't want this data to change in my program. Um, Tuples are good also for little one-off stuff where it's not going to change. Anything that folks are curious about or have questions on around tuples before we move on?
Are you able to put like in each index of the tuple, are you able to put like a list as an index or a dictionary as an index?
Good question. Yes, I see where you're going with this, and let's find out. Well, maybe. I'm not sure. Let's find out. Right? Because if we can do this, can we modify the list inside it? Oh, and I should comment this line out because that causes an error. That does work. Let's see what happens if we modify it. It might actually work. I'm not sure, to be honest. That's a great question. So fancy tuple sub 0 sub 1 equals David. And we're going to change Alice Waters to David Waters and see if it works or if Python complains. I'm sorry, I changed the last name. So you can indeed change here what's inside the tuple. And this does sort of go back to pass by reference and pass by value. If I go ahead and hop over to TL draw for just a minute, and we go to our diagram from yesterday, and let me just get rid of all these things that we don't need. Actually, that will stay, and that will stay. So here's my fancy tuple. Let's talk a little bit about what happens when we create this. There's three things here, right? There's the tuple, the two lists. I mean, there's really more because there's each string, but somewhere in here, I'm pretty sure what happens, and I'm not like 1,000% sure, but I'm like 75% sure, is it sticks a list in memory. Right? And we have our other list of our other user. And can everyone read this? Okay. Okay, awesome. And then we have the fancy tuple itself. Let me change the color here. And what we have is this variable fancy tuple points over to this location in memory, A1. But what's in here? Pointers or references to other locations in memory. Right? Because if I tried to do in my code, if I did fancy tuple sub 1 equals whatever, I'm going to get an error. It won't let me change this. We saw me try that a moment ago. I'm going to do it right now just to prove it to everyone. I'm going to try and change the second list, not something inside the list, but rather the second element of the tuple itself. And fingers crossed, we get an error, right? Because the tuple says, hey, there's an element here and there's an element here, but the tuple doesn't know what's inside each element. So I guess I had to put a little bit of an asterisk after my statement about true immunity versus const, because this is actually exactly what's happening with const as well. And truth be told, what's going on here is that each of these lists, it does get confusing, right? This one points to a location in memory. This one points to a location in memory. And in fact, we don't have all the words in here. Over here, we've got Alice, Waters. And over here, we've got this list that points to memory location A4 and A5, where those strings live. And it's the same thing with Carol King, right? Where that object, because a string is an object, Carol is here over in A6, and King is over here in A7. And over here, this list just contains pointers or references to where these other things are in memory. And I want to check in how people are feeling about this, because I realize that this diagram is a bit ad hoc. Does this make sense? Does it feel like a bit much? What's on people's minds? On a scale of like 50 to 100. Oh yeah, Jack.
I'm tracking.
I mean, I'm tracking. I will say that this diagram for me is confusing, but I kind of already know a little bit about tuples, so I'm here. But this diagram is a little confusing for me.
Yeah, I already agree. The diagram I came up with on the back of a napkin.
I think it makes sense to me because it's like if you're changing the content of the indexes, the tuple is just like referencing to a specific location and not a specific value for each list in it. So if you just change that content at the location it's looking for, the tuple is not going to care. So that makes sense, the diagram to me a little bit.
Yeah, I think the thing, yeah, and again, I know the diagram can use a little bit of work, um, and TLDraw is sort of defeating me here. The thing to take away from this, I think, is that like a variable is it's like, when you put someone's name in the address book in your phone, but then you still have to put the phone number or the email, right? It's an alias or a reference, and it points to somewhere in memory, right? But then because we can have other like objects in here, I don't have the actual values here. I have, it's like if you like, I mean, we don't really have encyclopedias anymore, but it's like pulling out the B book of the encyclopedia and then looking in the index to go to a certain page. Right? Because this list, well, the list is here, but the things in the list are somewhere else in memory. Is that, I know it's maybe not that much better, but is that a little bit better of kind of breaking it down in the diagram? Awesome. So just file this away because you don't need to use this on a day-to-day basis. But, Chase, that was an awesome question. And I know we've gotten a little off topic here. That's why I can't change this element of a tuple, but I can change what's inside it. Right. And there are some programming languages out there that are like functional languages that are purely immutable where you can't change anything, but Python is not that. So, even tuples, the immutability is limited. So I was totally wrong about that before. That said, you probably don't want to do this, right? Because it's confusing, but it sort of defeats the purpose of using a tuple, which is making our lives easier by making constant data that's never going to change immutable. If I have stuff inside a tuple that I want to change, it probably belongs in a list, right? It's like I can hang a picture upside down on my wall, but I probably don't want to. Or like I can put the couch, facing the wall the wrong way, but I probably don't want to. But it's really cool to see and experiment with. So yeah, Chase, great question, and everyone, great questions. Um, any other questions or things that people are curious about with tuples? Okay, cool. Let's see here. It's we're almost coming up on the hour. Why don't we take a break and then at 10 o'clock Central, we can pick it up with dictionaries? Does that sound good to
Bless you.
folks?
Yes, indeed.
Awesome. Yeah, and we're moving at a pretty good pace through stuff. So thank you very much, everyone. Have a good break, and I'll see you all on the hour. All right. So we were talking about kind of under the hood where Python is putting things in memory. And really every object has its own address in memory. And when we have these more complex objects that contain other objects. They contain references to other objects in memory. We're making pretty good time. I do want to talk about dictionaries, though I know we all have a degree of familiarity with them. I might briefly talk about sets. We might see a couple useful functions for dictionaries and lists, and we'll see some looping. I'll talk a little bit about conditional logic too, like if-else statements. We'll see a switch case statement that is sort of a variation on conditional logic. We'll see Python's version of the arrow function, map-reduce sorting, error handling, and then dealing with file paths and opening files and modules and stuff in Python. And that'll take us pretty far. And hopefully we can wrap that up. We can definitely wrap it up before lunch, hopefully with a little bit of work time. And then probably after lunch, I'll check in with you all, but then we'll look at testing in Python. Sound good? Cool. All right. Let's see here. This is a lot of code. I think I'm good to keep going though, because it's okay to have it all in one file. So let's go ahead and talk about dictionaries in Python. And I am going to do a little bit of copying and pasting of code here, just in the interests of time. So this looks an awful lot like a JavaScript object, but it's actually pretty different. We do have a key or a property and a value, and they are separated by commas. When I'm writing a dictionary like this, and we do use these curly brackets the same way for the block, I need to have the keys in quotes. JavaScript, I could do this, right? That's not how the Python language is designed. The key has to be, I believe, a string value. And I can have, and in Python, instead of camel case, like we see in JavaScript, the convention is to use snake case, where you put underscore between words and you keep everything lowercase, except for classes, which we'll learn about next week. I can have dictionaries have lists inside of them. I can have dictionaries have other dictionaries.
So the declaration of the dictionary is the curly bracket.
Yes, sir. That's exactly it. Yeah, exactly. If I create a list with the square brackets, it's creating a dictionary with the curly bracket. Let me go ahead and print Jeff. And I forgot to comment out this code that is intended to produce an error. And now let's print Jeff. So this prints out the dictionary. We'll talk about importing later, but I want to show one thing real quick. I am going to jump to the top of this file, and I'm going to import a function, well, really a class from the Python standard library called pprint, which is short for pretty print. And I'm going to use it here. And as you can see, it does exactly what the name implies. It pretty prints the dictionary. So this can be useful for debugging. You can give it a lot of options. But I just wanted to show that really quick. Once I have a dictionary, um, there's two ways to access keys and values from it. I can use bracket notation and note these really nice hints that I get from the VS Code editor that I can navigate up and down with the arrow keys. I can also use .get, which will get the key and print it out. And the nice thing about .get is I can give it a default value so that if the key isn't in the dictionary, it returns a default value. And this is useful for two reasons. The first is so that you can have a default value. The second is that with the bracket notation, if the key isn't in the dictionary, then it throws an error. While with .get, it will handle it safely. And like I think here, if I don't give a default value, it probably just returns none. Let's see what it does. And I have an extra. There we go. I was missing a closing parentheses on the other line of code. And I forgot to comment out the line that causes the error, and let's run that code one more time. And we can see here that get will handle that error and return none as a default if that key doesn't exist. So that's actually really useful. We're
So
gonna
the
see a couple.
first,
Yeah,
you said it's called a default. I'm sorry, I just had a, yeah. So what is the second one called?
you mean like no upcoming vacations over here?
Yeah, like if the upcoming vacations is a default value, like what is, yeah, no
Ah,
upcoming vacations.
got it. Other way around. The first argument to get is the thing we want to look up from the dictionary, right? Like if I did like right here, this first argument is the key that we want to grab. The second argument is the default value if that
Is
key doesn't exist. And if I don't give a default value, it just uses none as a default value.
So if you have a key that it exists but it doesn't have a value, is it just going to return like undefined?
I don't think it's possible to create a key that has no value. I don't, in fact, think undefined exists in Python. Like, with JavaScript, we had those keywords like let, right? And I could do this. We don't need those to create a variable. This isn't going to fly in Python. This will produce an error. I don't think Python has undefined. So I don't think there's a way to do it. I could set it to none, but none, like null, is an actual value. Yeah, that's a really good question. Someone can Google it to double check, but I'm about 95% sure there is no such thing as undefined in Python. Um, what else are people curious about, or other questions about dictionaries and this .get method? We're going to see some other dictionary stuff in a bit. Let's look at
I
functions.
actually do have
Yeah.
questions. Um, so if we had another person inside of this dictionary too, how would we differentiate between like what set of information we're trying to get?
Mm, got it. Yeah, and we can actually use address as an example for that. So let's say I want to get Jeff's zip code. Um,
Is it the indentation?
uh, so you raise a good point actually, and I didn't mention this. Indentation does matter in Python. Like we'll see this with functions better in just a minute. Indentation and white space actually has meaning. I'm actually not sure if this will throw an error or not. So that works. You wouldn't want to do it. So that, the indentation here indicates layers of nesting, right? Um, and so here we have an object nested inside another object. And that would be one way to do it. And, I could, of course, I can make a list of users and I could put Jeff inside there. And if I wanted to, I could,
Functions,
do like name.
functions is coming up next. Add them if you want to show them when you go over functions.
Say that again, James?
I say you're gonna be going over functions next. So if you want to show them the indentation during the
Yeah.
functions part.
Yeah. Yeah. We'll see that then. In terms of how do I get Jeff's address? Like, how do I get this nested stuff?
That, but also like if you had Alice in the same dictionary as well, like if your dictionary was all your users and you had, I don't know, your whole company's log in there, like how would you differentiate
Like that?
between, yeah.
The
So
same way that I get Jeff's address, zip code right here, I could get Alice's name. But with dictionaries, it is all about keys and values. So you have to know the name of the key that you're looking for. You probably want a list of users where each user is its own dictionary. But you could do it like this, or as to your point, and now I've got a dictionary of users, right? Yeah, and now I see what you were saying. And this is how you would do it. And the same way here, I do like Jeff address zip. I would do, users, Jeff, name. Let's talk about functions. And functions open up a bunch of cool things in Python. So we got to use this statement called def, which is short for define, as in create a new function. We would pass arguments in here. We don't need the curly brackets like JavaScript. We just use a colon. And then I could say, print inside, give me 5 function, and it's going to return the value of 5. And that's all I need to do. Then let's go ahead and execute or call this function. And we should see our message printed, right? And then we will also see that value 5 returned and printed as well. Now, white space, this empty space and indentation matters in Python. It's meaningful. The reason Python knows this is not a part of the give me 5 function is because of the indentation levels. If I do this, Python thinks this is all part of the same function, right? So this is not good. Python doesn't think these things are inside this function. And in fact, we're going to get numerous errors because of that. Right? It expected an indented block. So indentation is part of Python's grammar. It's part of its language. If I want to make an empty function with nothing inside of it, I can use this special statement called pass that just is a placeholder, just so Python knows that this is not in there. And I could execute that function and it just won't do anything. I'm not going to execute it, but we wouldn't see a difference if I did. We can pass arguments to our functions. Let's actually, sorry, I'm jumping ahead a bit. All right, and this will print out 4. I can add multiple arguments, and the order of arguments matters. So this function, by the way, if you don't have a return statement, implicitly Python adds return none. So this function returns none. Arguments are required in Python, unlike JavaScript. It'll throw an error if I don't put them in there. The position matters, right? The first one's got to be the number. The second is the color. And I can add default values to arguments. And now I don't have to pass those values because I've set a default value that Python will use. And I do it with the equal sign like this here, where I define the argument name for the function. And this is extremely useful, and you will want to do this a lot. It does mean that you have to call the function a little differently and pass arguments a little differently. I think this throws an error. That does work. Yeah, now that these have become named arguments, I can refer to them by name. So if I want to use that default value of 1 and just set the color, I can do it like this. And the order no longer matters if I'm passing the values at the named argument way. And I just want to check in and see if folks have questions or things you're curious about this, because this is super useful. Cool. Another useful thing is, let's say I want a function that takes an infinite number of arguments, I can use this special keyword. It's called star args, and it's sort of like a list. And then the argument is not star, it's args. The star is sort of a special symbol. And if I call this, and then I run my code, we see that what happens is it prints out everything in here. This is actually a list that Python creates for us and sort of under the hood exists all the time. For instance, I could do this. You probably wouldn't want to, but if I want to print out like the second thing in there, I think that should work just fine. Yep, we can see that star args gives us a list named args that has all the arguments we pass. I just want to check in and see if folks are curious or have any questions about star args.
So essentially, it's doing a map with a custom list that you provided.
It's not really doing a map. I think the way to think about it is when you call a function and you pass in arguments, under the hood, Python is sticking all of these into a list. And it's doing that all the time. Most of the time, we just don't worry about it because we give our arguments names. But if for some reason, like say on the command line, whereas you all know, like the ls command, there's the -a flag and the -i flag, and there's all these different commands that you can add it. And maybe there's a directory path as well. I don't know how many arguments that would be passed into the ls function. This is where this is useful to collect them all into a list. Does that help answer your question?
Yeah, it does. I just had something twisted. It's good now.
Yeah, totally. So with great power comes great responsibility. Don't do this unless you need to. Because the worst thing in the world is something like this. When I look at this function and I want to call it and use it, if like I have to dig through sorry, let me put this stuff. Let me get rid of that. And I've seen this. Imagine like a function that's like 100 lines of code and it's using star args and you have to dig through it to figure out what the heck the arguments are that need to be passed and how to use them. And that, this is a list, right? So I have to get, something from here, and it's like the third thing in the list, and maybe this is a dictionary, maybe it's a string. Who knows? Every language has like a philosophy and design principles, and one of Python's is explicit is better than implicit, and that's a good one in general. Like, what arguments matter here? I don't know. I can't tell. It's implicit. It's way better to be explicit. Right? Sometimes you need this, but if you don't need it, don't use it. There is an even more powerful version of this called star star quargs, which stands for keyword arguments. And it lets us do this, but for keyword arguments, for named arguments. And let me just print this out to begin with, and let me run this and we can talk about it. And let me make sure I've commented out. Yeah, let me comment out that so that function doesn't run. And at first, this might look great because, oh man, I can save some typing. But again, you'll very quickly find that you'll look at code you wrote like 3 days ago and you'll be like, what the heck does this code do? So check out what star star quargs does. This one gives us a dictionary where each keyword argument becomes a key and a value in the dictionary. And we'll talk about looping through dictionaries in a bit, but you can loop through dictionaries. And so I could do something like this. Where you can get the key and the value. It's good to know about this. You'll need to use both of these once or twice, but you generally don't need to use them and should avoid them unless you need them. Do folks have questions around star args or keyword args? Okay, cool. I am going to make a new file just because this one has a lot of stuff in it. I'll close the old one out. Let's talk about if statements. And these we've seen, and there's not too much magic here. Let me just write a function that we're familiar with from yesterday to figure out if someone is of age to drink beer or not. And I'll talk about the differences between JavaScript and Python as I do. If statements in Python, I don't need the parentheses. I don't have to worry about all that double or triple equals nonsense. I can just use plain old double equals or, greater than or equal to, less than or equal to, instead of logical and logical or symbols that we saw in JavaScript. I can use plain old language like and or. And it would help if and I just stick a colon at the end side of my if statement. I don't need JavaScript curly brackets, but I do need to indent so that stuff is inside the if block. Instead of else if, we type elif, which is just short for else if.
Do you need parentheses on the other side of the or is that implicit?
I do not need parentheses because of the order of operations of these logical steps. Because of this first one here, if this evaluates to false, if it evaluates to true, we're good to go. If it evaluates the false, we hop over here, right? And now we're on the other side of the or. And let's say this is true. We still have to continue on to the and because it's an and. We need both the things on the left and right side of the and to be true. If this is false, we would just stop.
That makes sense.
I totally get what you're saying, and there's no harm in adding parentheses if it makes it easier to read. But because of the sort of order of operations and how these logical operators work, they're not necessary for this particular statement.
Okay.
Does that make sense?
Yeah.
Awesome. Yeah, great question. So if you're in Antarctica, I guess everyone can drink. And finally, we can have an else statement, and we'll return false here. Code blocks are determined by indentation. This is not inside the if statement. This is outside the if statement. That will throw an error. This is not inside that else if. It's outside of it. That will throw an error. That will throw an error. This would be outside of that final else statement, right? So indentation matters in Python. And we'll just put USA. And let's go ahead and print out what this says. And that should have printed. I need to save the file, and now we can run it, and it'll print out true. So this is if and else statements. The and the or actually make life really easy. We could also do there's also, I think, an equals if age. I think you can just say is. I'm probably spelling centurion wrong. But you need the double equals, I think, for string comparisons. For other things, you can just say is. It's really useful for true and false. That's when you see is come into play. I think this code will run. No, and I was wrong. It does indeed need to be, let's say, we can only use it with booleans. If is special is true. I mean, and honestly, this can actually be simplified to if is special, since this is a boolean here itself. But I just wanted to show is there and how we can use the booleans in our if statements. Any questions around if statements before we move on to looping? Okay. We've been going for a while too. How are we doing in terms of energy? Okay, awesome. Let's take a loop. Let's take a look at switch case. And there's a couple more fancy things, but we're getting closer to the finish line. I think I'll just move a bit quicker through some of the things I think we've seen. So Python makes looping really easy. Most of the time, you don't need to do like a for statement with a counter like you do in JavaScript. Python kind of knows that you can loop through a list. And so I can just do for x in my list. And this can be any variable name that I want. I can go ahead and print the thing. And again, indentation matters, right? This is not inside the loop. And we print out the things in our list. If I want to get like numbers from 1 to 10 for some reason, I need to use something called arrange. And I need to tell it what I want to count by. And let's see here. It doesn't like it. You can see here why the indentation matters. I could put pass here. I think it's better just to comment that whole bit out. And so the range, the start is inclusive, right? It's not 0 indexed. We started at 1 by default. Oh, no, we didn't. I'm so sorry. We are 0 indexed. Just goes to show that, like I said, no one remembers all this stuff. Stop is exclusive, right? We get 10 values, but we're not printing up to 10. We print out 10 values, but it's 0 indexed. So I apologize. This may be a little off, but we get 0 up to 9. You can do a lot of nifty stuff with ranges. I won't show all the examples, but if we hover over it, we can see here there's start, stop, and step, just like we saw with our list. So I could do for X in range, let's say maybe I want to start at 0, stop at 20, and print every third. And I think I got my syntax right there. And now all of a sudden, I can print every third thing. This is really useful. Arrange does not create a list. Like if I do this, we're not going to get what you might intuit and first expect. Arrange is its own special object, and it's kind of meant to be looped through. So you have to do stuff with it. It doesn't create a list, which I think is the natural assumption to make. Any questions about ranges? Cool.
Yes.
Yeah.
With range, when do you use the bracket notation compared to parentheses notation?
Oh, with range?
Yeah, I feel like I've just seen it also with like
Yeah.
brackets. I don't know. I'm guessing that's
Yeah.
like step or
Yeah.
something.
I think you're thinking of like, if we have a list and I do like my list and it's like this, and then it was like 0:5, 2, like we were doing earlier, like something like this.
Yeah, and even seeing it right now, it kind of just answered it for me.
Yeah, for sure. No, that's a great question, and you raise a great point. And that actually touches on something really important. In Python, the brackets are for like accessing keys, right? Like if I want to get the second thing in the list, I use the bracket notation to access, I shouldn't say accessing keys, for accessing stuff, whether it's an element in a list or a key off of a dictionary. Brackets are for accessing. But then Python lets us do this fanciness where I get to stick like this miniature program and this tiny set of rules where I'm telling it to access a whole bunch of stuff. And I think that's the source of the syntax confusion, because you're right, we see the same thing here. Under the hood, lists and ranges are both something called an iterable, I think, that to be honest, I'm a little rusty on in Python and that we don't have to worry about right now. But like Python, the language, as a special construct of things that can be looped through. And that's why there is that commonality between lists and ranges. Yeah, great question. There's another way to loop through a list. And in fact, now that I have, I'm going to get rid of that just so I don't lose track of stuff, and we'll make that like 1. So I've got that list of my 3 things. If for some reason I wanted to, when I loop through the list, also get indexes, I have to use something called enumerate. There's like iterables, and I think an enumerable in Python as well. And again, it's an area I'm a little rusty on, and we don't have to directly use it, though it is very cool. But what I can do is this. So let me write this out, and then we'll kind of hover over enumerate and see what it does. And you can pass in multiple things to be printed. And let me just run this code so we can see what it's doing. And we can see here. And by the way, is everyone like, can everyone see the terminal? Okay, I realize there's a lot of stuff on the screen. Okay, cool. If it is kind of information overload, let me know and I'll figure out maybe a better way to organize it. We can see that we printed out the index and the value, but we kind of did it by like turning the list into this enumerate object. And you can see like enumerate takes this thing that's an iterable. Like I think I could have actually passed in a string. We'll try that. Maybe we'll try that in a second. Certain kinds of objects in Python can be looped or iterated through, such as lists and other things, and ranges. Enumerate will return a pair of tuples, actually, and it creates a count. So it's not actually getting the list index, it's creating a count, and it gives us each thing in our iterable. And so it actually gives us these tuples. Like, instead of this, we could do for the tuple in enumerate by list, print the tuple. And if I run this code, we see what enumerate is actually giving us. Don't worry about this too much. This is sort of peeking under the hood of Python a little bit, but we don't have to deal with it too directly. Most of the time, we're doing it this way as well, to be honest. I am curious real quick to see if this works with a string. And indeed it does, right? And I'm pretty sure under the hood that strings may be stored as lists in Python, but don't quote me on that. If someone wants to Google, like, is a string a list in Python and share with the class what they find out, that would be cool. But here we can see like a string is iteratable. We can go through that. Tuples are iteratable, right? This should work just fine. So there's a number of things in Python that are iterable. And it's a really useful concept. We can also loop through dictionaries in a similar way. If I have a dictionary, right? And I do have the black formatter set up now, by the way. And if you note, when I do format document, it's going to change those single quotes to double quotes and get rid of some spaces. If I had more things like this, at a certain point, if I make this long enough, the formatter will put the keys and values on different lines. And I can loop through the dictionary, but the default way to do it just goes through the keys. Don't depend on the order you create stuff in a dictionary. Python will loop through it in the order you define it, but that's not a behavior you should depend on. If you need to care about the order of the stuff, you should be using a list. If you need to care about the order of the stuff, use a list. And now I can go ahead and I can print out keys and values from a dictionary. You can loop through just the values, which can be really useful because I might not need the keys. Dictionaries have a lot of really useful built-in methods. One of them will return just the keys. Another will return just the values in a list. And so if I know I only care about the values, I can do this. And very succinctly, in like 2 lines of code, print out all the values in my dictionary. Any questions sort of around these dictionary looping techniques? Yeah, Python is definitely a language where it pays to dig into it a bit because it has so much useful stuff. Finally, Python has while loops. As I said the other day, avoid them. I don't like them. The one thing while loops are good for is user input, like if you're writing a command line program. And you all will write a command line program. And you'll probably need a while loop for the user input. And it'll look something like this. User exit equals false, while, not user exit. And then you'll have to do stuff to get prompts from user. And finally, user wants to quit. So we say user exit equals true. And then it would exit the while loop, right? And this is sort of your classic user interface loop, though, there's like dozens of lines of code that I've sort of hidden behind these comments. All right. We're almost on the hour. Why don't we break? Because I think we're kind of moving on to a new topic anyway. So I do apologize, folks. I had hoped to get through all this stuff this morning, but hopefully we're moving at a good pace. Let me pause the recording and we can talk about the plan for the rest of the day. All right. So we've covered a lot of ground with Python. We might talk about sets a little bit. We might talk about iterations. We're going to see some cool built-in functions. We're going to see how to find an item in a list. We're going to see what a switch case is, the Python version of arrow functions, lambdas, map filter, sort. And then this file path stuff is really going to be the sort of newer stuff in the air handling. And this will be the second half of the lecture before lunch. And where we were was we were looking at dictionaries and the cool things you can do. Everything in Python being an object means we get just all these really useful methods, like to get all the keys in a dictionary in a list or to get all the values, and then we can just go ahead and loop through them. So similarly, because everything in Python is an object, even strings have different methods that we can use. And by the way, VS Code has incredible autocomplete. It's giving me all the different methods that this variable has. And VS Code autocomplete isn't perfect, but it's pretty darn good. And if I click on this little arrow here, it will even give me a little hint explaining what this is, right? And so use the dot and the autocomplete, like use VS Code autocomplete to explore stuff. I'm actually not sure what the centering does. Something interesting. But the one we want to use is capitalize, right? Because how nice is that? So there's a bunch of nifty built-in methods like this. If I wanted to, say, replace a letter, I could do that as well. It will look for the character I want to get rid of and replace it with something else. And it looks like I did something completely wrong here with replace. I think the issue may be this might return a new value. Let's see. I assumed this modified in place, but maybe I'm wrong here. Yep. So this is actually really good to see. Right? And we were talking about pass by reference, pass by value. Replace doesn't modify the existing variable. It returns a new copy that it's modified. It returns a new variable. The old one is unchanged.
Is the replacing this like the replace in JavaScript where it only replaces the first instance and not all of them unless you do the global flag?
I don't know. I would have to look at the docs. and the details. It looks like there's a count, so you can tell it how many to replace, and if you put -1, it will replace all of them. Last thing I think I want to show is we've seen lists. We've seen that I can, add someone to the list to the end of the list with append. But I can also remove someone with pop, just like we can in JavaScript with arrays. And pop will return the thing we've removed and modify the list. Right? And I see here, I add David, I see him there, I pop him off, I get him, and then the list is back to 3. And there's a good number of list methods. I can also use some built-in methods to find someone in a list.
Can you pop a specific element, or is it like last element type thing like Java?
Last element. Yeah, great question. Pop actually the term comes from this data structure, the stack of pancakes, which we'll learn later. But that's why append and pop only deal with the last thing. You would use like a slice operation if you wanted to remove something in the middle. And if I want to find someone in my list, I can just do if and in, which is so useful. Now, I have to be careful because, strings are case sensitive. So it's a good habit to lowercase stuff. You can also find stuff in a dictionary the same way. If I have just a dictionary of foods, and do I have a dictionary in here already? I do. I'm going to copy this and paste it down here just so we can see it again. And we'll call it foods. And I'll comment all these out so I don't get the errors. And I can search both the keys and the values. The same way I would look through it. Now, it depends what we want to do. Searching through the values this way may be more or less useful depending on what we need to accomplish, because this doesn't actually give me that key value pair itself. Let me start up another examples file here because we're going to have some new things. Close that one out. So the first one I want to show is user input from the command line. And if we look at the prompt here, when I hover over this method input, the description is reads a string from standard input. Everything in Linux is kind of organized, and actually every single program that we've used on the command line, whether it's ls or cat or anything else, if it's printing stuff out to the terminal, it uses these like this. There's standard input and there's standard output, and then there's ways to share errors. So all these command line programs actually kind of conform to a bit of a standard. And so we can use this input function to get input from the command line. And let me actually add a print statement here so we can see something useful after I run this. So note a couple things. Execution has halted, right? Python started running our program on line 1, but until the user types input and hits enter or quits the program, execution is paused. And then we print out the language that we want to learn. And it sure would be nice to have a space here just so things look nicer. Any questions around user input? Cool. And the great thing is it's as straightforward as it seems. It's one of the great things about Python. Let's talk about switch case statements, aka match statements. JavaScript has these as well. You don't use these as often. They're like if-else statements, but they're useful for scenarios where your logic might not get as complicated. There's some other things you can do with them that are a little special, but we're just going to see the basics right now. So I'm going to take match desired language, and we're going to do case JavaScript. And this is like an if statement. And I add, just like I would have a bunch of different if statements, I have different cases for each one. I can also have a sort of everything else case. I remember I said yesterday underscore is a placeholder that we don't care about. This is indicating to other programmers, hey, this could be any value. We don't really care about it.
Instead of using the underscore colon, could you just use default?
I'm sorry?
Is that shorthand for default?
I could put any variable name. Is it shorthand for default? Will that work? I think this will work. It's more of a convention. Let me come back to that in a bit, and I'll double check.
What if
Um,
I got a
what was that?
question? What if like for the user input, they put something that's like not a string, like say they put like an integer or something like that.
Great question. When I type 123 on the command line, is that a string or an integer?
It's a string
Yeah. Why is it a string?
because all user input is passed as a string, and then if needed, it's cached as another
Yeah.
type.
All the command line can do is print text in terms of when it prints stuff. And exactly like you said, if we do need to get a number, I actually have to cast it from a string to an integer. Yeah, great question, Case. Let's go ahead and run this real quick and watch our code in action. Well, it sort of worked. We saw here we got to my default case, right? But I typed Python. Why didn't it print out this Python case?
Because you capitalize Python.
Capital P, yeah.
Yeah, exactly. Right? So the way to do this, when you're creating your data, lowercase everything. It makes life simpler. User input always needs to be validated formatted and parsed, whether to change the format, deal with casing, convert the string 123 to the integer 123, or to make sure it won't break something. So make your life simple by having your text data be lowercase, unless it's, like whole sentences and stuff like that, and manipulate the user input. So over here, I'm just going to do lower because input returns a string, and I know I want to lowercase it. And now from here, through all the rest of my program, the desired language is lowercase. Problem solved. And if I run my code now, I'm good to go. There was a great question. Does this have to be underscore? Let's find out real quick. Yeah. So what this is what this switch case statement does is it does a comparison. If desired language equals JavaScript, but I think it does it with a little bit of regex as well, like regular expressions for pattern matching, because these cases can get a little bit more complex. And like I could have, whatever equals, I could do this, and then this matches to this string, right? And so this is, you could think of it as a base case is the term sometimes for similar stuff. This is basically our everything else default case. And so I just need some variable to be here that'll catch everything.
Am I
I can
thinking
name it whatever
of?
I want.
I might be thinking of Java, but can't you just do case colon?
I don't think so, no.
Okay, I
In
might be
fact,
thinking
we get the
something.
red squiggly expected pattern expression. Yeah. Python needs some sort of pattern here to evaluate. And that pattern here, it's just a string matching, but it can get a little more complex. So we do need something. So this is just a variable name. The variable name underscore indicates this is a placeholder. We don't care about its value. Yeah, great question.
Another quick one, sorry.
Yeah.
I don't know if you went over it, I might have missed it or space out. Does it have to be like an exact match? Or if there's like a capital somewhere, is that gonna mess it up?
The way I'm writing this now with these strings, it does have to be an exact match. For example, if I run the code and I do JavaScript 1, it's not going to match here. Now, JavaScript works, but it works because JavaScript with a capital J, but it works because I lowercase the input.
Okay, yeah, I didn't see
Yeah,
that dot lower. Thank
exactly.
you.
For sure. Yeah, great question. You can do stuff here, I think with the star, like regular expression stuff for more complex, it's called pattern matching. And that's where this kind of gets useful, but that's a little out of scope of right now. In general, I would just use if else statements, to be honest, and start with that. And only if you feel like maybe this makes your code simpler, use a case match. This is a good example of kind of when it's good. Like I know it's like if I know I've got like 4 inputs and it's going to be one of these 4 things, then a case match might be good. Or if I want to do some fancier pattern matching, but in general, the if else I think is the right starting point. And in fact, let me go ahead and just rename this one to user input match statement, because that's a nice one to have. In JavaScript and other languages, this is often called a switch case, because instead of match here, it'll say like switch, as in like a switch that goes between different settings. In Python, it's called a match case. So you'll hear me say switch case, match case. and like all sorts of portmanteaus. Okay, good. And we have this open. So I think I can just close this out. Excuse me. All right. Now we're going to look at something a little funkier, which is Python lambda functions. So normal functions in Python are first class. Like we learned about yesterday, I could write a function named say hi. And let's just have it print the name. And I can call it in the way we're all familiar. I can also pass it as a variable, assign it to a variable, or pass it as an argument to another function. And if I run my code, this executes this function, right? A first class function can be passed as an argument or assigned to a variable. And so similarly, I could and this is a toy example. I don't want to get into the weeds of building more complex examples to show why this is useful. I more so just want to demonstrate the technique where, again, we're passing our function as an argument. And I wanted to just briefly review this because just like JavaScript has arrow functions, Python has lambda functions. And let me show you what they look like. And let me write a normal function and a lambda function so we can see the two together. So if I'm writing a really simple function that's going to add 2 to a number, it would look like this, right? And 3 plus 2 is going to give me 5. If I'm writing that as a lambda function, it would look like this. And I'm going to do add 3 just because I can't name it add 2 as well. I use the keyword lambda. After this are my arguments. Then instead of the arrow like we saw in JavaScript, we use a colon. And here's the body of the function, right? The body of the function is all the stuff inside it, including the return statement. And the body of this function adds x and 2. And because it's a one-liner, I don't need a return statement. And in Python, I think lambda functions have to be one-liners. They're really meant to be small. If you're writing a lambda function and you need like 2 or 3 lines of code, turn it into a normal function. And I use it the same way I would any other function, right? And I can add 3 to 6, and I should end up with 9. So this syntax, I know, can look a little funky. If we remember from JS, it would look something like this. I don't know if that helps or makes it more confusing, but these are exactly the same thing.
What exactly is the X colon? Is that like, so you do lambda and then is that like the variable name and then the break, or is the X dot colon just the equivalent of the equal arrow?
The colon is the equivalent of the equal arrow. The X is the argument that we're passing into the function. So like the same way that the X here is the argument we're passing into the function. Like this, I could make it Y, or I could name it like, my number. So the syntax is a little weird with lambdas, but what we've got on the left side of the colon is the arguments we're passing into the function. And then on the right side is what we're doing inside the function. Does that help answer your question?
Yes, to the T.
Awesome. Yeah,
Does
great question.
does the lambda do a callback to the add to function? Is that what it was?
We are going to use a lambda in that way, but there's nothing magical about a lambda function itself. You can literally, like, this is just another way of writing a function.
Okay, no, that makes actually sense. Thank you.
Yeah, exactly. And in fact, let's put 2 here, and we'll call this just add 2, put a lambda. And so it literally, and this needs to be my number. This lambda and this are exactly the same. And the reason you see X and all these little things is because, once you get used to it, this is actually easier to read. It's confusing in the beginning, but once you get used to it, the shorter variable name is easier to read.
I got a,
We
I got,
need to,
I got a quick question. Sorry.
yeah, no, absolutely. That's what this is for.
Okay, so if you have multiple arguments, because I noticed in your examples you just have like, the one argument, where you just separate that by commas. Like if you had like two or three arguments.
Yeah, I think it's either going to be commas or we're going to have to add parentheses. I honestly don't know off the top of my head, but the best way to
It's
find
commas.
out is always just doing it. What was that?
It's commas.
It is commas. Okay, perfect. Yeah, I wasn't sure if I needed to wrap with parentheses like JavaScript or not, which I honestly like the parentheses. I don't think Python wants that. So good tip, when you're running little code experiments to figure stuff out, make your data simple. 1 and 2 is 3. We add another 2, that gives us 5. If we get 5, then we did it right. Yeah, great question. And let me just add a add 3. Let's call this add more. Well, I get a little obsessed about naming because it makes a huge difference when you're writing code, but it does mean when teaching sometimes I've been doing this for so long, it's like a physical impulse I have to stop to not refactor code in certain ways. Lambdas are, every now and then you use it as one-off, but kind of like you were saying, Chase, lambdas are useful for when we want to pass a function as an argument to another function, specifically with map and list. And let me just write this code, and then we can talk about it. We saw this a bit yesterday, but I think this will make it easier. I'm not sure why I keep opening terminals. Map, list, reduce. Let's say I have a list of numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I want to add 2 to all of these numbers. I want to end up with a new list that has, 3, 5, or 3, 4, 5, 6, 7, 9, 11. And I'll write the code out because it'll be way easier to see. We're going to map. And excuse me for just one moment as I make sure I get this right. Yeah, okay. My apologies. I'm so used to the JavaScript syntax, I always struggle with this one a bit. So we use the function map, and we need to create a Lambda function inside it. And it's doing what we saw before. This is a function that takes a number and adds 2 to that number. The second argument of my map function is my list. And this is the part that I got confused on, is looking at this syntax. So the first argument here is actually a function. The second argument is the list we're going to map over. And just to reiterate what map does, map goes through each of these and applies our function to it, right? So it loops through the list, but then it applies our function to it. And let me just move everything over a bit so we can see it. And then what we end up with is a new list where all these values are mapped.
And does
Or
that
rather,
have
we've
to be
created
a
new
Lambda
values.
function, or can it be a high order function too?
It's all kind of the same. So map is a higher order function because it takes a function as an argument. Yeah, a higher order function is just a function that takes another function as an argument. And for the life of me, I can't seem to write adding by 2 out correctly. I don't know why my brain is struggling with this.
Yeah, it should just count up. Yep.
But that is what that should actually be right. Right. And let's maybe just add like 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh yeah, it'd help if I add the last number there, and we're gonna cheat. There we go. So hopefully this visual illustrates why it's called map. We're kind of creating this new value, but we don't get rid of anything in the list, right? It gets mapped into a new list. And so that's what this map function does here. And then if I run this, there's undoubtedly something I'm forgetting here. I think part of the issue is that map does not return a list. If we look at this, in fact, so it's a little hard to see, but when you're reading this VS Code stuff, this right here it's called a function signature. And what you see, a function signature is the number of arguments and the type of arguments, right? we've got two arguments. The first argument has to be of type function. The second has to be of type iteratable, like a list. And then the signature is the type of thing the function returns. And in this case, it returns something called a map object. And so the easiest way to do it is for let's call it like new thing in new list, print new thing. I'm sure there's a one-liner to turn the map object into a list in Python. I'm not sure what it is off the top of my head.
Isn't it using the string or the repr dunder?
No, it's an actual object. The same way like range doesn't give us a list, it gives us this special object. Python.
I figured out you could just wrap like the new list in a list. So print
Oh,
parentheses list
that I
parentheses
think
new
you're right.
list. That works.
Yeah, I think that'll do it. Which is
Print. Sorry.
oh yeah, thank you,
Yeah,
thank you.
yeah. List and then the new list, and that'll
Yeah,
work.
yeah. And that's again this idea of an iteratable in Python, like things that can be iterated through. Thank you so much. Map isn't meant to be treated like a list. Like we can't like. And Chase, you're right. It does get into the dunder repr method, but we'll learn about that next week. So this turns this sort of map object into a normal list, though we could also loop through it if we wanted. I could have also done I could have done this. I don't necessarily have to define the function inside the map. The function might need to be a lambda, but I'm not sure about that, to be honest. But I could define a lambda function somewhere else and use it here. You often see it done like this because once you get used to it, it's useful to have it all on one line. Let me demonstrate filter and reduce because I want to make sure we have enough time to cover a couple other things, and I probably went a bit deep into this one. So I do want. So my apologies if folks have questions. In the interest of time, I just do want to keep the ball rolling. Sound good?
If you put list outside of the map before the lambda function, just encapsulate that entire thing with list.
Yeah,
it'll convert it.
I want to move on. I apologize, just because we have to see filter and reduce and sort and a bunch of other stuff. But I think the easiest way to answer that question is going to just be to run the code and do it, because 5 gets you 10. I don't know that answer off the top of my head, and that's exactly what I would be doing now anyway. And again, my apologies. I just want to make sure we have time to cover the things that we need to. And also, like, you're not going to use map, filter, and reduce in Python a ton. You actually use them way more in JavaScript. Let me show you guys filter in Python. So it looks really the same. We're going to, and maybe when we build this, I can come back to your question. We're going to use filter instead of map. I need to create a lambda. It's going to take each item in this list as an argument. Filter needs to return a Boolean true or false to decide if it stays in the list. Right? If map is creating a new list, what filter is doing, filter is also creating a new list, but not everything stays in it. And I want every number that is divisible by 3, right? I want to see if the remainder dividing a number by 3 is 0, and this percent sign is modulo. So like if I do 6 modulo 3, there's no remainder. If I do 5 modulo 3, I get 2 because that's the remainder. 4 modulo 3 gives me 1, right? 3 modulo 3 gives me 0. 2 modulo 3 gives me, 2 because nothing fits in there. So if something modulo 3 is 0, it means 3 divides into it evenly. So we're only going to see here 3, 6, 9, right? So unlike map, filter doesn't produce a new list with the exact same number of items. It gets rid of stuff. And again, I pass in the list and we have a new list. Let me print this and then actually I can tackle the question that someone had. And so fingers crossed, we should see 369. And indeed we do. And what was the question someone had about, it was like wrapping map with a list or something like that?
It wasn't a question. I was saying that if you wrap, you can use a cast list around your map lambda function to auto cast your answer as a list instead of having to do it separately.
Sure. Yes, that exactly. Like instead of this, I can do this.
Correct.
Yeah. That can be good. We probably will want to use it as a list most of the time. It just depends what we're doing with this.
Yeah, it just avoids not being able to print the map object.
Right. Yeah, they both accomplish the same task. What questions do folks have about filter? Okay, let's see one more of these, and it's called reduce. And reduce is a little different. And let's put it down here. And reduce is going to look like this. It actually takes 2 arguments. AGG stands for aggregator, as in like something that we're going to add everything up into. And reduce doesn't actually produce, it may or may not produce a list. It produces one thing. And what reduce does is, and let me write it out and then we'll talk through it. But I do need to run an import statement. Because we don't have this like map and filter. It's not kind of built into Python, but functional tools, functional programming tools is part of the standard library. Um, and you're not going to use reduce that much, so don't worry about it too much. What ends up happening is this aggregator thing, we add everything together. Like right in here, I add stuff together. So if I kind of walk through what's going on here, it would look something like this. And I totally jumped to the wrong spot, so bear with me. Well, that was, I do apologize. I'm not quite sure. Oh, I'm so sorry. I'm not sure what key I hit here, and we lost our diagram. Let me just write the code and talk through what reduce is doing. And I'm going to copy and bring my list over here so we can write the code and talk about it. This aggregator, it gets passed in every time we call the Lambda function, and we keep adding stuff into it. We're reducing every element in this list into one thing. And in this case, we're doing it by adding it all together, right? So the aggregator here, it probably starts off as, I don't know, 0. So it probably, or none or something. So we can just think of it as 0 plus 1 to get started. Right? And so 1, 2, 3, 4, and so on. And we're adding them all together and we're saving that value. And we're going to do that for all the things in the list until we add them all up, until we reduce or combine them all into one thing. You won't use this as much. You won't use this as much in Python. It is quite useful when you do need it. And this one is probably the trickiest of the bunch, so I don't want to get too lost in the sauce on it.
I
More
appreciate your
use.
explanation. Just because, I could always use the reduce statement, but I couldn't really understand or visualize what it's doing, so that helps a lot.
Awesome. Super glad to hear. Yeah, I feel like reduce took me the longest by far. And all of these come from this paradigm of functional programming. And when we get to React.js, you'll see it pop up a lot more. You use it less in Python, but you will see lambdas, and you will see lambdas in some of the tests that you'll need to understand for the OOP assessment. So it is good to get familiar with lambdas. Yeah, I'm glad that this was useful. The last lambda, I want to show 2 more things, and then we'll stop because I realize we hit lunch, and we'll just have to pick it up after lunch. But these 2 things are really good. So I know it's been a long hour, and we've sort of saved the best for last, because one of them is sorting, and it's super useful. Sorting is super useful. So let me show you all sorting. And how are we feeling, by the way, just about writing Lambda functions, like on a scale of like 10 to 20?
Probably around like 16, 17,
That's
Yeah,
about
it's
right.
like right in the middle.
Yeah, that's about right. It's the concept is a bit strange, and the syntax is new, and with Python especially. So that's about exactly where you should be. You will not have to write a ton of Lambda functions. You'll have to read some. Every now and then you might write one. Most of the time you'll write normal functions. And again, if your lambda function starts to get complicated, that's a sign you should just turn it into a normal function. Like, for instance, well, I can't do it with this one. I'll try to show it at another point. But let's talk about sorting, because this one is nice. I am going to do a little bit of copying and pasting in the interest of time, just to pull in some code for a dictionary, because I don't want to type all of that out. So bear with me one moment here.
You could use zip to do it quickly.
Yeah, we're gonna see zip in just a second. That's what's coming up right after this. So this is, and I do apologize. We're really sorting a list here, but it's a list of dictionaries, and I want to sort them by age, right? I want the first thing in the list to be the youngest person, then the middle-aged person, then the oldest. And there's no way for Python to know this, because people.sort, well, what's Python going to sort it by, right? It's not just a list of names. And this is where a lambda function is super useful, because we can tell Python how to sort it. So we're going to tell Python what key to look for in the dictionary to sort. And if we hover over this, you can see that it's sort of designed for this. You can use it for stuff other than dictionaries, but this is such a common scenario where you have a list of dictionaries that Python has given us some tools. And what this does is Python will take this lambda function and use it to come up with a value for whatever's in this list. So what my lambda function is going to do is, for the purposes of sorting, just for the purposes of sorting, come up with these numbers, right? Because once I tell Python how to get these numbers, it can sort them, right? I could have done it by name if we wanted to sort alphabetically, but I'm choosing to do it by number. And this is a great use case for a lambda function. And the way to do it is we're passing as an argument to this key argument the whole lambda function. And the variable here, it can be k, it can be x, it can be whatever name we want to give our argument name. Let's just call it like person, because each dictionary represents a person. And we're saying, hey, grab the age property from that dictionary. And print, let's see, people, my guess is we'll probably have to convert this to a list, but let's just run it and see if I have any typos. Actually, it did it for us. And if I look in here, right, nothing got replaced, but everything got sorted. There's a bunch of different options I can give this as well, which is pretty cool. I think, for instance, I could do a reverse sort. And this sorts in place, by the way, which I hadn't realized. But it makes sense, because why would we not want to sort the actual list? And it looks like I might have something wrong here. Yeah, I'm not going to worry too much about. It's a different argument, which is a little confusing to me. So let's leave printing that out there. Let me get rid of the annotations because that's probably a bit confusing at this point. And what we can also do, if we want to get a new list, is use this function sorted. And we can pass the same lambda. And I'll name it the same so that it's clear. And we can also pass this argument reverse equals true. And now I've got my reverse sorted list, but the original list is still unchanged if we wanted to look at that. The last thing I want to show is zip, which someone mentioned, which is super cool. And then we'll wrap up because I realize we're running a bit long. So thank you all for being patient with me. So let's take a look at zip. It's for dictionaries and it is great. Well, really for lists and dictionaries. And let's say I have some numbers in a list. Let's say I have some letters in a different list. And I really, really, really want to put them all together. And forgive me, I'm kind of jumping around a bit here. But let's go ahead and combine them with zip. And let's see what zip gets us. And let's go ahead and print our numbers and letters. And I think there's one more step I have to do here.
Cast it with
Because cast it with what?
dictionary.
Oh, thank you. Right. My apologies. Yeah, if we take a quick look at this, it's its own type. And we can turn it into different things. I can turn it into a dictionary with dicts to cast this into a dictionary. And the first set of things in the list becomes the keys, and the second become the values. I could also turn it into a list if I wanted to. And I get a list of tuples where the first thing is the key and the second thing is the value. So zip is super useful and one of your best friends in Python. And this is definitely a good stopping point because we've ran a bit long. So let me just see if folks have any questions before we wrap up and break for lunch.
I'm assuming zip can only be used for lists, not objects, right? Or, sorry, dictionaries.
Yeah, I'm pretty sure. Um, I'm pretty sure. And because also for dictionaries, what would we be doing? Like, let's say I had food equals um, uh, and let's say I had, I don't know, dessert. So with lists, it's pretty clear we combine this with this, this with this with this, right? And that's because keeping things in order is part of a list's job. With a dictionary, just because I wrote sushi and pizza here, well, what if for some reason I change it around like this because I have like 100 foods and I want to put them in alphabetical order? It wouldn't make sense for Zip to combine these things together. That said, I actually don't know if there's something fancy that Zip does with dictionaries. I don't think so, but it never hurts to ask. And actually, I was totally wrong. Let's see here. What does it do? Well, so this is cheating because they turned the dictionary into a list of its keys. So it's not actually doing anything directly with the dictionary. Here we do appear to be doing something with the dictionaries. I actually don't know what that does. Let's see what that does. Yeah, this is a great question. So let's just say zipped dict equals zip food dessert. Let me comment out my print statement. Undoubtedly, this is going to be of, type zip, and we're going to need to do something to it. But let's just make sure the code runs. It does. So let's turn this into a list and see what it looks like. Interesting. It has combined all the keys together into tuples and then the values. And now let's see, if I put sushi here, it's probably going to change the order of them. Yeah, I really don't like depending on the order of things in a dictionary. I might be wrong about Python best practice, but it just rubs me the wrong way. And if we turn this into a dict, let's see if this does anything interesting. That one seems a bit trickier because we seem to have lost some information along the way, in fact. So, great question. I actually did not know this about Zip. I think the use case is a little less clear with dictionaries, but it does do stuff with dictionaries. Any other questions before we break for lunch?
Just for me to like double check. So the zip takes, if you give it like two arguments, it takes the first takes the same index or element from both places and then attach them together, right?
Yeah, and
Okay.
I really think it makes sense to just think about lists with Zip. You
Okay.
give it
Just
two
wanted to check.
lists, it adds them together. You can probably give it a third list, in fact. And now if I print this out as a list, I bet we're just going to see a list of tuples, and each tuple has three things in it. Right? That one is from the dictionary. We can ignore that. And this is why Zip is nice with lists, because this is intuitive. Like, I want to put all the things from like a bunch of lists into one tuple. I can do it with Zip. Or I want to see that as a dictionary. I can't do it with three things in the dictionary form, but I can with two. Does that help illustrate the behavior of list a bit more, Chase? Awesome.
When I ran dict on nums and letters, it just returned an empty diction, like a empty set of curly braces on nums and letters when there was only numbers and letters and they're not words. So if you take
Oh,
away words, if you take away the words out of nums and letters, and then
yeah.
just run dict, it's just an empty dictionary.
Oh, well, you raise a good point. Actually, that's a good point. I convert this to a list, and then I convert it to a dict. This does an in-place modification of nums and letters. We only get to do one conversion here because this is like a zip object, and we've turned it into something else, and now there's kind of nothing left. Watch what happens if I comment this out. Now we see that dictionary, right? And if I had the order reversed, we'd see the dictionary, but the list would be empty.
Huh.
So this is really the way to think about this is it's like a conversion operation. And nums and letters here is not, it's not a list or a dictionary, right? It's class zip. And Python, the way this zip function is really designed, they're expecting us to turn it into something else. But they're kind of expecting us to turn it into something else once, which kind of makes sense if you think about how you would use it in the real world. So this is a bit of a gotcha. So I'm very glad you mentioned that. Thank you. Because that is potentially super confusing. This is also where like reading the docs pays off. If we read these docs somewhere in here, it will explain why it's designed that way, and it will probably make sense. But to be honest, there's so much stuff to read, I wouldn't worry about it too much. Let's break for lunch. I know we've ran a bit long, so I appreciate it, and I apologize for eating into the lunchtime. We'll reconvene at 1:30 Central to look at air handling, file paths and importing, and writing tests.
So you said in for those of us not in Central so like an hour and 10 minutes?
Yeah, an hour and 10 minutes. Yeah, and I apologize for eating into lunch. We can do a bit more. We can do it like let's do an hour and 20 minutes from now, just so we have a bit longer of a break. And I'll throw the timeout in the Zoom chat.